Alright, so let's start off by drawing two isolation diagrams. So for the outer mass, we have that the only force on it is from spring 2, which is coefficient k. The force is just k times delta x2 in the direction of its acceleration. Now for the inner mass, there are two forces acting on it. First spring, which is k times delta x1, and the second spring, which is k times delta x2. So from the first isolation diagram, using Newton's second law, we get that the net force, which is k times delta x2, is equal to the mass times the acceleration, which in this case is the outer radius r2 times omega squared. Now, we know that r2 is just the two lengths of the springs, which is 2L, plus delta x1 plus delta x2. So k delta x2 is just m omega squared 2L plus delta x1 plus delta x2. So delta x2 is just m omega squared over k, which is q times 2L plus delta x1 plus delta x2. Now from the second isolation diagram, we have that the net force, which is k delta x1 minus k delta x2, is equal to the mass times acceleration, which in this case is the inner radius r1 times omega squared. So this should be r2. Now the inner radius r1 is given by L plus delta x1. So that means that if we isolate for k delta x2 is equal to k delta x1 plus m omega squared r1, which is L plus delta x1, and dividing by k, we get that delta x2 is equal to delta x1 plus q times L plus delta x1. Now, substituting in delta x2 into the first equation, we get that delta x1 plus q L plus delta x1 is equal to, from this equation we have q all times 2L plus delta x1 plus delta x2, which is delta x1 plus q times L plus delta x1. And now we just have delta x1 in terms of q and L. So simplifying all of that, we get that delta x1 is equal to L times q 3 minus q all over 1 minus 3q plus q squared. That's part of it. So from part A of the problem, we found that delta x1 is equal to L times q times 3 minus q all over 1 minus 3q plus q squared. So in this case, delta x1 diverges when the denominator, 1 minus 3q plus q squared, goes to 0. So we must solve the quadratic equation 1 minus 3q plus q squared is equal to 0. Now using the quadratic formula, we get that q is equal to 3 plus or minus square root of 3 squared, which is 9. Minus 4 times 1 times 1, which is 4, all over 2 times 1, which is 2. Now, to find the minimum value of q, we must take the root with the minus sign. So we get that q min is equal to 3 minus square root of 9 minus 4 all over 2. Therefore, human is just 3 minus square root of 5 over 2.